Welcome to topic 9.3. In this video, instead of subtracting, adding and subtracting like terms, we are going to multiply these polynomials together by combining like terms instead of adding and subtracting them. However, with this, we're going to have a different process. And there are some different methods to multiplying polynomials. However, I will be teaching what is called the box method. So the one thing that you have to pay attention to, especially once you get outside, or especially if you take the test for this unit, is that take a look, notice how between these two binomials, and a binomial is just a term used to describe a polynomial with two terms. So this polynomial here, x plus 1, we have a term here and a term here. So since there's two terms, that's called a binomial. So since these two binomials here don't have an addition sign in between them, that is indicating to us that we're multiplying those two binomials rather than adding them. So pay very close attention. If there's no operation, like if there's no addition or subtraction between two binomials or polynomials, that means that we are multiplying them. So without further ado, let's get started. Now, for this first example, I'm going to start out by drawing a box. So I'm going to draw out the box right here. Now, and in this box, I'm going to draw a line vertical like that, and a horizontal line like this. Now, above this box, I'm going to take this binomial here, x plus 1, and transfer that down here. So what that's going to look like is x plus 1. And I'm going to transfer this binomial here, this x plus 3, down over to this side of the box. So I'm going to do x plus 3. Now, what we have to do is we have to look at each individual box that we made here and multiply the two things that match up with that box. So let me first just walk us through each individual box. So this first box here, we're going to have to multiply x times x. So I'm going to write x times x. And this box right here, we're going to do x times 1. So x times 1. And then here, for this box, we're going to do 3 times x. So this is going to be 3 times x. And then this last box here, we're going to do 3 times 1. And 3 times 1. So I'm going to simplify this box out a little bit more. Well, actually, I'm just going to write all of this out here. So we have an x times x. So I'm going to do x times x. I'm going to add x times 1, which is just x. And then 3 times x, I'm going to add that, which that is just 3x. And then 3 times 1, that is just 3. So, looking here, we have x times x. And remember, from our first section of this unit, we can use rules of exponents to simplify this because we have an x and an x, which is the same base. And this x and this x have an exponent of 1. So we're going to do x. 1 plus 1 is 2 plus x. Well, we can also combine these like terms here. Because notice we have an x and an x, and we're adding them. So x plus 3x, that is going to be 4x. So we have x squared plus 4x, and then this 3, it's just on its own. So something we can do with that. So we're going to add that 3. And that's our final answer. Now, I know that that was a lot. And don't worry, because we're going to work through some more example problems where we get more practice with this. And just give yourself some patience, because this takes a while to grasp. So just be patient, work through some more examples, and you'll start recognizing more of the trends, and then eventually you'll get a lot more fluid at this. So looking at example 2, we have x plus 3 all squared. So what does that mean? Well, remember, whenever we have something squared, that means we're just going to multiply that thing by itself 2 times. So x plus 3 squared just equals x plus 3 times x plus 3. That's what that means. Same thing as if we were to have 3 squared. Well, we know 3 squared is 3 times 3. Same thing here, just we're dealing with we're dealing with letters or variables instead. So x times 3 squared is just x times 3 times x times 3. So now let's draw out a box to multiply x times 3 and x times 3. Let's see what we get. I also encourage you to pause the video if you're feeling confident enough to do so. Just give it a try. Okay, so I'm going to transfer one of the x plus 3's here at the top. I'm going to transfer the other x plus 3 off to the side here. So I'm going to do x times x, and x times x, remember we can just add the exponents. It's going to do x to the 1 plus 1, which I'm just going to, if you need to keep that x 1 plus 1 there, you can keep that there in the box, but I'm just going to erase that, and I'm going to put x squared. And then here we have 3 times x, and 3 times x is 3x. And then in this box we have x times 3, which is 3x. And then in this box here we have 3 times 3, and 3 times 3 is 9. Now we are now going to take everything that's in this box and add them together. I should have specified that in this first example, because I did not make that super clear. But whenever you're multiplying polynomials or binomials and you use this box method, once you get everything in this box, you then add everything within this box, and that'll be your answer. So here, notice if we add everything in this box, this 3x and this 3x, they are like terms. So we can add those together. So I am actually going to circle this 3x and this 3x in green. So then I can make this a little bit more clear. So we have x squared plus parentheses 3x plus 3x close parentheses plus 9. So this is going to be x squared. Well, 3x plus 3x, that is going to get us 6x. So we have x squared plus 6x plus 9 is our final answer. Now looking at example 3, I encourage you to pause the video and try this on your own. And now let's work through it together. So we have y minus 4 times y plus 2. So the process is still the same. Even though we're dealing with y rather than x, everything is still the exact same process. Nothing is going to change in terms of our process. So I'm going to transfer that y minus 4 to the top of this box. And then I'm going to transfer the y plus 2 to the side. So y in this box here, we're going to have y times y, which is y squared. And then in this box here, we're going to have y times negative 4, because this 4 is being subtracted, so this becomes a negative 4, right? So we're going to have y times negative 4, which becomes negative 4y. And then we have a positive 2 times y. So positive 2 times y is just 2y. And then here in this box, we have 2 times negative 4. So 2 times negative 4, remember, negative times positive is going to get you a negative. So we have a negative, and 4 times 2 is 8. So let's add everything together and combine like terms. So we have this 2y and this negative 4y. So we have y squared, and then it's y squared plus 2y minus 4y minus 8. So we have y squared, and then 2y minus 4y, that's going to get you negative 2y. It's going to be minus 8. Looking at example 4, we now have something originally in y. We have a y squared now, but don't let that scare you, because nothing's going to change. Our process is going to be exactly the same, except for our answer is just going to look a little bit different. That's all that's changing here. So I'm going to transfer that y squared minus 2 on top. So y squared minus 2, and then y plus 2. So here in this box, we're going to do y times y squared. Now remember, we're going to add those exponents. So it's going to be y to the first power times y squared, which is y to the 2 plus 1, which is y cubed. And then here in this box, we're going to erase this y to the first. We're going to have y times negative 2. So this y times negative 2 is going to be negative 2y. And then here we have 2 times y squared, or positive 2 times y squared. And that is going to be 2y squared. And then here we have 2, positive 2 times negative 2. Positive times a negative is a negative, and 2 times 2 is 4. Now remember, when I said that this y squared is going to change our answer, that's because here, notice that 2y squared and negative 2y, they're not like terms, because we have a y squared versus just y to the first. So we can't combine those two. So in this case, we aren't combining any like terms for this answer. So all we're doing is simply taking what we have in the box and adding it together. So we have y cubed plus 2y squared minus 2y minus 4. And that is our final answer. Alrighty, so looking at our final problem of this section, we have x plus 1 cubed. So remember, like we did in example 2 here, x plus 3 squared means we just multiply x plus 3 by itself 2 times. In this case, because we have x plus 1 cubed, we're going to multiply x plus 1 to itself 3 times rather than 2 times. So x plus 1 cubed equals x plus 1 times x plus 1 times x plus 1. Now, let's use order of operations, PEMDAS, and work from left to right. So let's first start off by multiplying x plus 1 times x plus 1. So, step 1, x plus 1, times x plus 1. Let me make this a little bit more clear. There you go. So step 1, we're going to multiply the x plus 1 and x plus 1. So let's first start off by drawing the box. And I encourage you to pause the video and work on multiplying x times 1 times x plus 1 on your own before I go through it, just to make sure that you're understanding this, this content here. And now let's work through it together. So I'm going to bring this x plus 1 to the top of the box, and then I'm going to bring the other x plus 1 to the side. So here in this square, we have an x times x. So x times x, remember that equals x squared. And then here in this box, we have x times 1, which is 1x. And then here in this box, we have 1 times x, which is also 1x. And then here in this box, we have a 1 times 1, and 1 times 1 is 1. So let's combine our like terms. So we have a 1x and a 1x, and we can combine them. So we have x squared plus, well, 1x plus 1x, that's going to be 2x. And then we have that 1 on the bottom. So we now have this polynomial. But remember, this is just x times 1 times x times 1. So this equals the same thing as this, right? So because that equals the same, because this polynomial here equals this polynomial here, we can take this and multiply it by the last x plus 1 that we have. Now, the only thing that's going to change when we use our box method is we're going to have a row, or we're going to have a column of 3 boxes because we have 3 terms here. But everything is going to stay exactly the same. So I'm going to draw another box. I'm going to make it, I'm going to draw that over here. I'm going to make the top part a little bit longer or elongated. And I'm going to draw a horizontal line in the middle. And then I'm going to draw 2 lines vertically. So one here and then one here. Not perfect, but it'll do. So I'm going to transfer this polynomial here, or this trinomial, because it has 3 terms, up to the top of this box. So we have x squared plus 2x plus 1. I'm going to transfer this binomial here, because it has 2 terms, off to the side on this box. So we're going to have x plus 1. So now let's multiply it. Let's multiply everything to fill in the boxes. So we have an x times x squared for this box, and an x times x squared is going to be x cubed, because x to the 1 plus 2 is going to be x to the 3rd power, or x cubed. So moving on over to this box, we have an x times 2x. So we're going to bring out that 2 in front. And x times x, remember, that is x squared. And then looking at this box here, we have an x times positive 1. So that is going to be 1x. And then here, we have positive 1 times x squared. So that's going to be 1x squared. Now, looking at this box here, we have a 1 times positive 2x. So 1 times 2 is 2x. Or 1 times 2x is 2x. And last but not least, this box here, we have a positive 1 times a positive 1. So 1 times 1 is 1. And now, all we have to do to finalize our answer is add everything together and combine like terms if we have any. So let's look at our box to see if we have any like terms. We have an x cubed here, but nothing else in this box is x cubed. We have 2 times x squared. Do we have anything else in this box that is x squared? Well, we have this here, 1x squared. So because we have those two terms that have x squared, we can combine them together. Now, looking here, we have a 1x. Do we have anything else in this box that has an x? Well, we have a 2x here. So we can also combine these two together. And then this one is just on its own. So let's write everything out. So this equals x cubed. And then when we combine like terms for 1x squared and 2x squared, that's going to be 1x squared plus 2x squared. So 1x squared plus 2x squared, that is going to be 3x squared. So we have plus 3x squared. And then here, we're going to combine these like terms. So we have a 2x plus 1x. And that is going to be 3x. And then this one is just on its own. So we're going to add that one. And that is our final answer.